Hello and welcome to Easy Sleep Science. Tonight we'll look up at the night sky, a vast and beautiful space filled with light, wonder, and endless mystery. Above us are familiar sights, the moon, the constellations, and the planets we often see. But beyond them lies so much more things far beyond our sight. Some of the stars you see have long since died. Only their light is still traveling toward us. A faint cloud in the sky may actually be an entire galaxy millions of light years away, and the brief flash of a shooting star may be nothing more than a grain of cosmic dust. The night sky is both familiar and extraordinary. We see it every day, yet it never stops, inspiring awe. If you enjoy peaceful journeys like this, please subscribe, or leave a quiet thought below. It helps other souls in search of calm find their way here, one person, one dream at a time. For now, simply rest, relax, and let the stillness of the night sky carry you away. Let's begin. Every star visible to the naked eye belongs to our own galaxy. When you step outside on a clear night and let your eyes adjust to the dark, the sky seems endless. Yet all those tiny points of light are just our close neighbors, members of the Milky Way. Astronomers estimate that under perfect conditions, the human eye can see only about 6,000 stars across the whole sky. That's a tiny number compared to the hundreds of billions that truly exist within our galaxy. The more distant galaxies like Andromeda or the faint spirals at the edge of the observable universe are too far away to be seen as individual stars. Their combined light blurs into misty streaks. What we see is just a small cross-section of the immense stellar community we live among. Some stars in the night sky have already died, but their light is still on its way to us. When we gaze at the stars, we are looking into the past. Light travels incredibly fast, yet space is so vast that even light takes years, centuries, or millennia to reach us. A bright star 100 light years away shows us its image from a century ago. That star might have already swelled into a red giant, collapsed, or exploded as a supernova. But its light continues to race through the void, reaching us as if time itself stood still. That means the night sky isn't a picture of the present. It's a moving archive, a living record of what once was. Every beam of light above us is both present and gone alive and fading at the same time. The North Star Polaris hasn't always been our guiding star. For those in the Northern Hemisphere, Polaris has long been a faithful companion sitting nearly above Earth's North Pole, marking true north in the sky. But Earth doesn't stand still. It gently wobbles on its axis in a slow cycle called precession. Over thousands of years, this motion shifts the celestial poles. Long ago, in ancient Egypt, the star Thuban in the constellation Draco was the pole star. About 12,000 years from now, Vega will take that place. The guiding star of humanity changes over time, a slow cosmic dance written across millennia. Ancient travelers once navigated across oceans and deserts by the stars. Before compasses or satellites, the sky itself was humanity's first map. Sailors crossing the Pacific memorized where constellations rose and set, using them to travel across trackless seas. Nomads in the desert did the same. Polaris, steady in the north, became their beacon. In the southern hemisphere, people used the Southern Cross instead. The Polynesians memorized hundreds of star positions, passing them down through chants and stories so they would never be forgotten. When you look up at the night sky today, you're seeing the same celestial signposts your ancestors once used to cross oceans and continents thousands of years ago. The Milky Way appears as a faint mist because we're looking through its disk. On a truly dark night, far from city lights, a pale milky band stretches across the sky. That's our galaxy. Its glow comes from billions of distant stars overlapping together. Since we live inside the galaxy, looking along its plane shows us that glowing ring like standing inside a vast wheel and looking through its rim. That's why we see a hazy ribbon spanning the heavens. Ancient people called it the river in the sky, the path of souls, or the backbone of night. Today we know it as the plane of our galaxy, home to hundreds of billions of suns and perhaps as many worlds. The Milky Way is both our home and our horizon. Within this galaxy are countless stars invisible to us. Most are small red dwarfs, faint, tiny, yet incredibly numerous. Some are hidden by clouds of dust and gas, visible only in infrared. There may even be endless wandering planets belonging to no star at all, drifting through the dark. So when you gaze at a star-filled sky, you realize just how small you truly are. A shooting star isn't really a star. It's a speck of cosmic dust burning up in Earth's atmosphere. These grains race through the air at tens of thousands of miles per hour, heating the air ahead of them until it glows brightly, then vanish. Most never reach the ground. What we see is their final shimmer, the universe's fleeting farewell. In the darkest places on Earth, thousands of stars appear. Far from the glare of cities, the sky comes alive, so full of stars, it can cast shadows. The Milky Way arches overhead in a grand, luminous curve. The faint smudges you see are distant galaxies, clusters, and colorful nebulae. Astronomers call these places dark sky reserves, rare sanctuaries preserving the untouched beauty of night. In many cities, the Milky Way has vanished under light pollution. Generations have grown up never seeing the river of stars that once shaped human culture. Artificial light hides the heavens, leaving only a few of the brightest stars and planets visible. But those stars are still there, waiting for us to lift the veil of light and look up again. Astronomers and conservationists are working to preserve dark skies not only for science, but for the sense of wonder that belongs to everyone. Seeing the Milky Way with the naked eye is to touch a shared memory of humanity. Constellations aren't fixed, they change shape over thousands of years. Each star in a constellation is moving through space on its own. Because the distances are so great, we don't notice this within a human lifetime. But over tens of thousands of years, those familiar patterns gradually warp. Orion's belt will skew, the Big Dipper will distort. Astronomers can even simulate the future sky, a time when today's constellations look unfamiliar. The night sky isn't a static picture, but a slow dance of the galaxy, proof of a living universe. In the southern hemisphere, the night sky opens a very different world. Familiar northern constellations like Ursa Major and Orion disappear. In their place are new figures, the Southern Cross and the two Magellanic Clouds, small galaxies orbiting the Milky Way, visible to the naked eye. Australia's first peoples call a part of it the celestial emu, and Sagittarius strides across the sky. Each hemisphere sees a different half of the universe, sharing one sky from two perspectives. The Andromeda Galaxy can be seen with the naked eye if the night is dark enough. It looks like a hazy patch, but it actually contains up to 1 trillion stars and spans more than 200,000 light years. Its light has traveled for over 2 million years to reach Earth, which means that when we look at it tonight, we're seeing a distant past from before humans existed, a humbling, breathtaking sight. During those more than 2 million light years of travel, countless living things have appeared and vanished. When that light left Andromeda, our ancestors had no language, no wheel, no fire. And now it reaches our eyes, an ancient message crossing space and time. One day, roughly 4 billion years from now, Andromeda and the Milky Way will merge into a single giant galaxy. But tonight, all we need to know is that this old light is still whispering about the universe's past. The night sky contains stars that no longer exist. It's easy to think stars are eternal, but they are born live and die sometimes in violent explosions. Because light takes time to arrive at Earth, many stars recorded by ancient observers have long since gone dark. Today's astronomers, when comparing old star maps, sometimes find points of light that once existed but have vanished. The night sky is therefore both a mirror of the present and a memory of the eternal. Some of those stars may have been very massive, exhausted their fuel, and exploded as supernovae, leaving only faint remnants behind. Others may have collapsed into neutron stars or black holes invisible without specialized instruments. The sky renews itself continuously. New stars are born even as old ones fade. What we see overhead isn't a fixed tapestry, but a changing story, a record of both what is and what was. Each twinkle is only temporary, even if its lifespan far exceeds our own. A star's color reveals its temperature from cool red to blazing blue. Not all stars shine the same way. Some glow with a gentle orange-red, others with a bright bluish-white. Those differences aren't mere makeup, they reveal temperature. Red stars, often red dwarfs or red giants depending on size, are cooler, only a few thousand degrees. Blue stars burn at tens of thousands of degrees with searing surfaces and short lives. Our sun, with its steady white-gold light, sits in the middle, a star of moderate temperature. To astronomers, these colors are like fingerprints. By splitting starlight into a spectrum, they can measure temperature, chemical makeup, and even motion. To the naked eye, star colors are subtle, often softened by the atmosphere. But with practice, you can still pick them out. Each hue tells a story about a star's nature, its energy, and where it stands in the cosmic life cycle. Stars seem to twinkle because of Earth's atmosphere. That sparkle feels magical, like nature's glitter, but it's actually atmospheric turbulence. As starlight passes through layers of air above us, it's bent and shifted by changing density and temperature. The effect makes the light appear to flicker or dance, even though the star itself shines steadily. Planets, by contrast, usually look steadier because they're closer and appear as a larger disk of light, less affected by the shifting air. Astronomers call this atmospheric scintillation, and it's why ground-based telescopes can't reach perfect sharpness. To compensate, observatories are built on mountaintops, where the air is thinner and steadier, or launched into orbit to escape the atmosphere entirely. That dreamy twinkle is really a reminder of the thin, restless blanket of air beneath our feet. In space, stars shine steadily. Astronauts on the International Space Station or spacecraft beyond the atmosphere see stars very differently from us. With no churning air, starlight arrives as perfect, unwavering rays. Instead of flickering pinpoints, stars appear crisp like fixed jewels on a black canvas. This clarity is one reason Hubble produces such spectacular images above Earth's air. It records the universe as it truly is. Stable light in space also reveals a star's delicate colors far more vividly than from the ground. While twinkle feels romantic, the view from orbit shows the sky in its raw form, stable, radiant, and pristine. It reminds us that the atmosphere both shelters and distorts, protecting us while gently veiling the universe's true face. Some stars grow hot enough to fuse helium and carbon deep within. A star's energy comes from nuclear fusion, squeezing lighter atoms into heavier ones. For most of its life, a star fuses hydrogen into helium. But massive stars don't stop there. As their cores grow hotter and denser, they begin fusing helium into carbon, oxygen, and even heavier elements. This process forges the raw materials of life. Every carbon atom in your body, every oxygen molecule you breathe was created inside a star that once burned bright. In the end, when they reach their limits, such stars collapse and explode, scattering elements into space to seed new stars and planets. The universe is like a recycling system. Each generation of stars creates the raw material for the next. When we look at a brilliant blue giant or a fading red supergiant, we're watching the forges shaping the future. Sirius blazes as the brightest star in the night sky. Sirius, the dog star, rules the darkness with its brilliance. In Canis Major, it shines nearly twice as bright as the second brightest star, Canopus. Its name comes from the Greek for scorching, and through the centuries it has lived up to it. Part of its brilliance is distance. Sirius is only about 9 light years away, a very close neighbor. But it's also intrinsically bright, shining more than 20 times more powerfully than the sun. Ancient Egyptians watched Sirius's first appearance at dawn and linked it to the Nile's floods. Today, it remains a reliable winter marker, visible even from cities. Sirius isn't alone. It has a faint white dwarf companion, the dense core of a dead star orbiting every 50 years. Sirius has inspired myths across nearly every culture, from ancient Mesopotamia to the Pacific Islands. Sirius is more than a bright point. It's a symbol, an omen, and a guide. Egyptians tied their annual rising to the Nile flood and built it into their calendar. Greeks linked it to heat and madness, giving us the phrase, the dog days. In Polynesian navigation, it's essential for long sea voyages. For many indigenous peoples of North America, it appears in legends and marks seasons. The power of Sirius lies here. Though it's just a blazing sphere of hydrogen and helium, it holds a lasting place in human imagination. The Pleiades sparkle like a cluster of tiny fireflies. The Pleiades, the 7 sisters, are among the sky's most beloved sights. This small cluster in Taurus is visible even where there's some light pollution. With the naked eye, most people see 6 to 7 stars, but the cluster contains hundreds. Through binoculars, the view becomes a brilliant swarm, each a youthful blue sun burning bright. Many ancient cultures knew the Pleiades, weaving them into myths of family or pursuit. The Japanese name is Subaru now on the carmaker's logo. The Pleiades are quite nearby, about 400 light years away, and still wrapped in clouds of dust that reflect their light. They remind us that not all sky-born beauty is distant. Some wonders are close enough to feel familiar. The Orion Nebula glows faintly within Orion's sword. Follow Orion beneath the famous belt is a short row of stars called the Sword. In the middle lies a faint patch, visible to the naked eye. Under dark skies, the Orion Nebula, one of the brightest and nearest stellar nurseries in the galaxy. Through binoculars or a small telescope, it becomes swirling luminous gas lit by newborn stars. Thousands of stars are forming there, carving the cloud with their energy. To ancient sky watchers, it was just a mysterious smudge. Today we know it's where the story of stars begins. At only about 1 to 300 light years away, it's among the most studied regions of the sky. Each look is a glimpse into creation underway. Some nebulae shine because their gas is energized by nearby stars. Nebulae are vast cosmic canvases, clouds of gas and dust, spanning light years. Some glow because powerful radiation from nearby stars excites their atoms. Ultraviolet light from giant suns slams into the gas, making it emit color. These are emission nebulae, painting the sky in reds, greens, and blues depending on the element. The Orion Nebula is a famous example, rosy from hydrogen. Without these exciting stars, the clouds would be dark and invisible, blending into space. Instead, they blaze like beacons, marking where stars are born. What looks delicate to our eyes is actually a roiling cauldron, shaped by energy and gravity, creating some of astronomy's most beautiful scenes. Other nebulae shine only by reflecting starlight like cosmic mirrors. Not every nebula glows on its own. Some simply scatter light from nearby stars. These reflection nebulae have a gentler glow. Dust grains inside scatter starlight, often giving them a signature blue, the same reason Earth's sky is blue. A classic example is the faint blue haze around the Pleiades, where bright blue stars light up fine dust. These nebulae are the universe's mirrors, catching and tossing light across the void. They often appear near young star clusters, places with lots of hot, bright stars to illuminate them. Though less dramatic than emission nebulae reflection, nebulae are the cosmos's soft whispers, subtle and exquisite. Many stars aren't alone, but come in pairs orbiting each other. We tend to imagine each star as a solitary sun. In reality, many aren't single. Binary systems, two stars orbiting a common center of mass, are extremely common. Some pairs are nearly equal, dancing around one another in balance. Others are mismatched, with a massive star pulling a smaller one into wide loops. To the naked eye, many binaries look like a single point, their closeness hiding their two-in-one nature. With telescopes, scientists can split them or infer them through gravity. These systems aren't rare, they may even be more common than single stars. Our solitary sun might actually be the exception. Binary stars remind us that even in vast solitude, companionship is common, and the universe is full of unexpected pairings. Binary systems may even outnumber single suns like ours. We tend to think most stars are like the sun, solitary with a planetary family. But surveys suggest the opposite. Binary and multiple star systems may be more numerous than single stars. In some cases, stars are born together in a single cloud and remain gravitationally bound for billions of years. In others, they capture each other later during close passes. A binary can be peaceful or stormy. A massive star can strip material from its smaller companion, creating a spectacular gas disk. Or one star may collapse into a white dwarf neutron star or black hole, altering the relationship entirely. For planetary systems, living under two suns would be very different. Imagine a sky with two sunsets, or a world with two sunrises each morning. Single stars like ours are special. but perhaps not the most common story in the galaxy. There are even triple and quadruple systems bound together. If two stars are already complex, nature goes further. There are triples and quadruples with intricate gravitational dances. In a triple, two stars may orbit closely, while the third circles farther out, like a nested waltz. In a quadruple, the structure can be more elaborate, a pair, orbiting a pair. To the naked eye, they may appear as a single point of light. A telescope reveals the truth, a miniature galaxy of its own. For planets within the sky would be enchanting multiple suns at dawn, and dusk overlapping shadows and light that shifts hue again and again. These systems remind us that the universe is wildly creative, arranging patterns far beyond what we're used to. Cepheid variable stars breathe in rhythm like cosmic lighthouses. Not every star shines steadily. Cepheids expand and contract in a regular beat, making their brightness rise and fall over days or weeks. To the naked eye, they seem to blink on a cosmic timescale. To astronomers, they're priceless. Their pulsation period is directly linked to their intrinsic luminosity. By measuring the heartbeat and comparing it to the brightness we observe, astronomers can calculate distance. This early 20th century discovery unlocked measurements of the universe's size. Cepheids became milestones pointing to nearby galaxies. Those rhythms once revealed the universe's true scale. For centuries, the size of the cosmos was a mystery. Were the stars close like pinpricks, or unimaginably far? Cepheid variables delivered the answer. In the 1920s, astronomer Edwin Hubble studied Cepheids in the Andromeda galaxy. By measuring their periods, he determined their intrinsic brightness, and thus their distance. The result was staggering. Andromeda lay far beyond the Milky Way's bounds. It was an entirely separate galaxy. This discovery expanded the universe overnight, transforming it from a single island of stars into a cosmos filled with countless galaxies. Cepheids are the keys, simple rhythmic beacons bridging the gap between us and the larger universe. Even today, with powerful telescopes and satellites, they remain essential tools for measuring cosmic distances. Each pulse is a heartbeat of the universe, steady and reliable, reminding us that the simplest patterns can unlock the greatest truths. Some stars swell into red supergiants hundreds of times larger than the sun. Not every star is small and steady like the sun. Some, near the end of their lives, expand into enormous red supergiants. They grow so vast that if one replaced the sun, its surface could extend beyond Mars's orbit. Despite their size, their outer layers are tenuous, glowing deep red as the star struggles to sustain itself. Inside the core is fusing heavier elements in a desperate effort to balance gravity. These giants live fast and die young, their immense energy burning through fuel at astonishing rates. They are rarer than smaller stars, but unforgettable in size and brilliance. To glimpse one is to see a star's final chapter, swelling unstable, destined to collapse. Red supergiants remind us that even the mightiest stars are not beyond time. Betelgeuse in Orion is nearing the end of its life. In the winter sky, Orion commands attention. On the hunter's shoulder sits Betelgeuse, a ruby-red star that has captivated stargazers for centuries. Betelgeuse is a red supergiant bloated to hundreds of times the sun's size. Astronomers know it is late in life, having exhausted the hydrogen that once powered it. Inside it now fuses heavier elements, moving toward an inevitable collapse. Betelgeuse's brightness varies dramatically, sometimes dimming enough to spark worldwide buzz. In 2019, a major dimming led many to wonder if it was about to explode. Though it returned to its usual brightness, the event reminded us of its fragility. Betelgeuse is a star at twilight with fate sealed. Whether it lasts another 100,000 years or only a fraction of that, it will end spectacularly. One day, Betelgeuse may explode as a supernova visible even in daylight. When it reaches its limit, it won't fade quietly. It will erupt as a supernova, an explosion so bright it will outshine almost every other star in the sky. For weeks or even months, its death light could be seen by day brighter than the full moon. Such events have occurred in history, recorded by ancient observers when nearby stars collapsed. Betelgeuse is about 600 light-years away, close enough for us to witness its splendor, yet far enough to pose no danger to Earth. The blast would leave a dense remnant, likely a neutron star, while its outer layers would fly into space, enriching the cosmos with elements like oxygen and iron. When that happens, people everywhere will look up at the same brilliant beacon, a reminder that stars live and die in extraordinary ways. A supernova can outshine an entire galaxy for a moment. The death of a massive star is among the most violent events in the universe. In a supernova, the collapsing core rebounds so fiercely that the entire star is torn apart in an instant. For a brief time, the explosion can release more energy than all the other stars in its galaxy combined. From Earth, such events appear as sudden new stars blazing where emptiness once was. Some fade over weeks, others over months. Beyond the spectacle, supernovae are cosmic engines scattering the elements forged in stellar hearts into surrounding space. Without them, the raw materials of planets and life would not exist. Their brilliance is fleeting, but their legacy is eternal. To imagine a galaxy dimmed by the death of a single star is to glimpse the power and impermanence woven into the universe's structure. The Crab Nebula is the remnant of an explosion recorded by ancient skywatchers. In the year 154, observers in China and around the world noted the sudden appearance of a brilliant new star. It shone for weeks, visible even in daylight, then gradually faded. Today we know it was a supernova, the death of a massive star. Its remnant still hangs in the sky, known as the Crab Nebula. Through a telescope, it appears as a tangled web of glowing filaments, an expanding shell of gas and dust hurled outward by the blast. At its center is a pulsar, the collapsed spinning core of the original star, still firing pulses of radiation like a cosmic lighthouse. The crab is a time capsule, a living bridge between ancient records and modern astronomy. When we look at it, we see both the memory of a star's death and the ongoing story of its remains. Pulsars spin with accuracy, rivaling atomic clocks. Pulsars are among the strangest objects in the universe. The collapsed cores of massive stars after supernovae, made almost entirely of neutrons, unimaginably dense. A spoonful of pulsar matter would weigh as much as a mountain. Many pulsars spin at incredible speeds, sweeping beams of radiation through space like lighthouse beams. From Earth, they appear as regular flashes of light or radio waves, so reliable that astronomers use them as cosmic clocks. Some rotate dozens of times per second. The fastest spins hundreds of times per second. Their stability rivals the best atomic clocks on Earth, enabling astronomers to measure cosmic distances and test the laws of physics. These tiny remnants remind us that time itself can be kept by starlight. Magnetars have magnetic fields 1 trillion times stronger than Earth's. Among the bizarre remnants of dead stars, magnetars stand out. Also, neutron stars, like pulsars, possess magnetic fields so strong they defy imagination, powerful enough to distort atomic structure. These fields can twist and crack violently, producing bursts of high-energy radiation that sweep across space, detected as sudden, short-lived, but intense flares. Though only about 20 kilometers across, a magnetar holds the mass of several suns. Their power is dangerous even across great distances. Bolides explode with thunderous sound as they break apart. A bolide is a fireball at the extreme, not just a streak, but an explosion. These brilliant meteors detonate in the atmosphere with enough energy to create flashes rivaling the sun and booms like rolling thunder. At times, they shatter windows or shake buildings, as in the 2013 Chelyabinsk event in Russia. Bolides occur when larger meteoroids, perhaps meters across, plunge into the atmosphere at supersonic speeds. Immense air pressure rips them apart, releasing stored energy in a burst of light and a booming shock wave. Ancient accounts of fiery skies and deafening blasts were almost certainly bolides. Though rare, they remind us that Earth constantly sweeps through a shooting gallery of debris. Most burns up harmlessly, but sometimes one arrives with dramatic force, rattling the ground and echoing through the night. Every night, Earth is brushed by tiny meteors. Even without a meteor shower, Earth quietly plows through cosmic dust. Minuscule grains, often no bigger than sand, constantly strike the atmosphere. Each one burns up instantly, too faint for most eyes to notice. Astronomers estimate that over 100 tons of meteoritic material enter the atmosphere each day. That means countless meteors streak above us, only a few bright enough to be seen. Now and then, larger bits flare brilliantly. Most vanish in silence. These dust motes are leftovers from comets, asteroids, and collisions in the solar system, drifting until Earth happens to cross their paths. Looking up is a reminder that the sky is never still, tiny. Cosmic travelers are always visiting, blazing briefly in the dark. Some meteors leave glowing trails that linger like smoke. Most meteors vanish in a blink, but some leave persistent trains hanging after the meteoroid has burned away. These trails form when an ultra-fast meteor ionizes the upper atmosphere, leaving a line of charged particles that glows. Depending on conditions, these trains can shimmer for minutes, twisting as high winds shift them, sometimes resembling smoke. But unlike smoke, they emit an eerie light of their own. Astronomers study these trails to learn about both meteors and winds at the edge of space. For sky watchers, they're the most magical moments of a shower, like a signature written across the heavens by a traveler between two worlds, fading as if reluctant to leave. The moon is our nearest and brightest companion in the night. Since humans first looked up, the moon has been a faithful friend. It's closer than any star, just about 384,000 kilometers away yet, endless in its shifting moods and shapes. The moon doesn't shine by itself. It reflects sunlight waxing and waning in a cycle that shaped our sense of time. Nothing rules the sky like it does. The moon guides storytellers, inspires poets, and serves as the natural clock of the earliest civilizations. Its gravity pulls the oceans, creating tides that shape life along the shores. Unlike wandering planets or fleeting comets, the moon is always there, rising and setting with a dependable rhythm. To step outside and see it is to share a view with every person who has ever lived. The phases of the moon were humanity's first calendar. Long before writing or stone tablets, people watched the sky. The most obvious cycle was the moon's from the newborn crescent to full, then waning, repeating every roughly 29 and a half days. Ancient people used that cycle to count time, sow, and harvest by the phases, and hold ceremonies at new or full moon. Many cultures still use lunar calendars today, shaping holidays and traditions around the world. Even the word month comes from moon. Watching it change night by night gave early humans a reliable rhythm of life. Unlike the sun's yearly cycle, the moon's short cycle felt close and visible, tying the sky to daily needs, turning heaven into a clock and calendar long before we made our own. A lunar eclipse turns the moon into a coppery orb. From time to time, the moon slides into Earth's shadow, and something strange happens. It doesn't disappear, but takes on a reddish-bronze glow. That's a lunar eclipse. The moon doesn't go dark because Earth's atmosphere bends sunlight, filtering out the blue and pouring the longer red wavelengths into the shadow. From the moon's surface looking back, Earth would appear as a black disk rimmed by a blazing ring of twilight. That red light bathes the moon and reflects to our eyes as a haunting blood moon. Under a clear sky during an eclipse, the moon feels both familiar and alien, still hanging above, yet transformed into a dim, ruddy stranger. These events last for hours, giving everyone on Earth's midnight side a chance to watch together. Many cultures once feared the blood moon as a heavenly omen. The eerie red of a lunar eclipse has always stirred the imagination. Before science explained it, people often took it as a warning. The Inca believed a jaguar attacked the moon and stained it with blood. In Mesopotamia, eclipses were seen as threats to the king, prompting protective rituals. Some indigenous North American traditions describe the moon being eaten or wounded, inspiring chants and ceremonies of recovery. Even so, not everyone was afraid elsewhere. Eclipses symbolized rebirth or cosmic balance. Today, we understand the physics, but the sight still carries primal weight. Watching the moon blush red in the night feels ancient, like touching the awe felt by countless generations. A total lunar eclipse can last more than an hour. Unlike the fleeting solar eclipse, a total lunar eclipse unfolds slowly and lingers. The moon drifts into Earth's shadow, dimming and reddening. Once fully immersed, totality can last more than an hour, sometimes close to 2. During that span, the moon hangs in a bronze cloak, muted yet still distinct. Anyone on Earth's night side can see it, making it one of the most accessible celestial events. Long ago, people gathered to tell stories of gods and omens. Today, families and astronomers do much the same, enjoying a show that needs no telescope, only a clear sky. When the moon leaves the shadow, its familiar silver returns, as if the world has been restored. The slowness makes a lunar eclipse one of the sky's most beautiful meditations. A solar eclipse sweeps across Earth with a racing shadow. When the moon passes directly between Earth and the sun, a shadow falls on the ground, and it doesn't stand still. It races across the surface, sweeping west to east at supersonic speed. From above, astronauts see a dark circle sliding over oceans and continents. On the ground, the signs are unmistakable. Light fades, temperatures drop, and a hush settles over the landscape. Only those standing within the narrow path of totality see the sun vanish behind the moon. Ancient people must have been terrified as darkness rushed in. Today, Many travel hundreds of miles to stand in that shadow and witness the rare geometry of three bodies in perfect line, a reminder of the delicacy and precision in the universe's dance. During totality, stars come out in daytime. Totality turns the familiar into the dreamlike. For a few brief minutes, the sun's glare is completely blocked at twilight at noon. In that strange light, stars appear. Venus usually shows first brilliance and unmissable, then bright stars like Sirius or Regulus. Mercury can sometimes be seen impossible on an ordinary afternoon. The world goes quiet. Birds roost, insects sing their night songs, and the air cools. Overhead, the corona unfurls the sun's delicate crown, normally drowned by daylight. Seeing stars glitter at midday is breathtaking, a reminder they're always there, patiently shining whether we see them or not. In those short minutes of totality, Earth feels suspended between two worlds, day and night, woven together. Ancient astronomers could predict solar eclipses with remarkable accuracy. Long before telescopes, they studied the sky with meticulous attention and saw that eclipses weren't random, but repeated in cycles. The Babylonians discovered the Saros cycle about 18 years, which let them forecast eclipses with notable precision. In China, imperial astronomers recorded solar eclipses as omens tied to an emperor's fate, keeping detailed logs for millennia. The Maya aligned monumental temples to the sun and moon, building calendars that captured their motions. Without modern science, these civilizations learned to foresee events that once terrified whole communities. Standing beneath a darkened sun while knowing it will return brings a feeling of mastery, proof that order rules the sky. Their careful records form the foundation of our understanding today, turning mystery into regularity, fear into reverence for the cosmos's rhythm. Venus is bright enough to cast shadows on the ground. Venus isn't an ordinary point of light. It's often the first star to appear at dusk, or the last to fade at dawn, a steady beacon overhead. Its brilliance is so strong that under the darkest skies it can cast faint shadows, a trick few bodies besides the full moon can perform. Venus shines so brightly because its thick clouds reflect sunlight extremely well. To ancient people, Venus seemed like two entities, the morning star before sunrise and the evening star after sunset. Only later did they learn it was the same planet. Galileo's telescope revealed Venus's phases like the moon's proof it orbits the sun. Today, we know that beauty hides a harsh surface heat and pressure that can crush any visitor. But from Earth, Venus still glows serenely, a splendid lighthouse bright enough to print its own shadow. Jupiter shines steadily, outmatching most stars. Jupiter is the king of planets, massive and majestic. To the naked eye, it's a steady point brighter than nearly all stars. Unlike stars that often twinkle through our atmosphere, Jupiter's light is stable, standing out among the constellations. Many ancient cultures revered it, associating it with thunder gods, power, and kingship. That steady glow hides a storm-racked world, bands of swirling tempests with the great red spot, a storm larger than Earth raging for centuries. When Jupiter rises, its presence is unmistakable. It grabs your eye and holds it. Watching it cross the sky is like tracking a giant moving slowly far beyond our world, yet so clearly seen. Each time it shines overhead, we're reminded of the solar system's scale, where even modest-looking points conceal unimaginable enormity. With just binoculars, Jupiter's moons appear like tiny jewels beside it. One of astronomy's simplest delights needs only steady hands, and binoculars look at Jupiter, and you can spot 4 little dots near it: Io, Europa, Ganymede, and Callisto. Galileo discovered them in 1610, shattering the belief that everything revolved around Earth. To the naked eye, they're tiny specks changing lineup night by night, yet each speck is an entire world. Ganymede is bigger than Mercury. Europa hides an ocean beneath ice, perhaps harboring life. Io is endlessly volcanic. Callisto is pocked with craters older than recorded history. Watching them drift around the giant is seeing motion on a cosmic scale, proof that other worlds orbit far beyond our own. Even now, that quiet ballet is as stirring as it was 4 centuries ago. Saturn's rings can peek into view in a small telescope. Saturn is the planet of understated beauty, a golden, tranquil presence in the night. It's lovely to the unaided eye, but through a small scope, the scene transforms. A world appears encircled by rings so delicate they seem impossible. Nothing else looks like it. The rings span hundreds of thousands of kilometers, yet are so thin they nearly vanish when seen edge-on. They're made of countless bits of ice, from dust grains to mountain-sized chunks, circling in glittering bands. Galileo was the first to see them, though his optics were too crude to grasp their nature. Today, they're still a favorite target for amateur skywatchers. These rings aren't eternal. They're slowly collapsing, raining particles into Saturn's atmosphere. In about 100 million years, they may disappear. For now, they remain one of the sky's most exquisite sights. Mars sometimes outshines even Jupiter with its signature red. On most nights, Mars is modest, a small ember among the stars. But every 26 months, Earth and Mars reach opposition, bringing Mars closest. Then it outshines every star except Venus, sometimes even rivaling Jupiter, flaring with deep red fire. Ancients took that fiery light as a symbol of war and blood, naming it for the god of battle. Through a telescope, it reveals polar caps, shifting dust storms, and valleys carved by ancient rivers. During major oppositions, Mars becomes a showstopper, bright enough to draw in even casual stargazers. Then it recedes and fades, its brilliance ebbing and flowing on a rhythm between 2 neighboring worlds. Each close pass is an invitation to peer across the gap at a place both alien and familiar, waiting for our return. Mercury is discreet, hiding near the sun's glare. Mercury keeps its secrets, hugging the sun so closely it rarely climbs high enough to see easily. Most people have never noticed it, though there are a few chances each year. It pops up briefly before dawn, or slips away after sunset, glimmering near the horizon before melting into the solar glow. To the ancients, it was the swift wanderer racing across the sky with uncanny speed, so tricky to follow that some cultures thought the morning and evening appearances were 2 different planets. Galileo's telescope revealed its phases like Venus and the Moon, confirming that Mercury orbits the Sun. Today, it remains a tempting challenge, a reward for patient eyes at its largest elongations. For those who find it, Mercury feels like a hidden treasure, a glowing coal at the edge of day. Uranus and Neptune may be just barely visible under pristine skies. The solar system stretches farther than early humans imagined, out to realms where faint worlds circle in silence. Uranus, a pale greenish dot, can be bright enough to see with the naked eye under the darkest skies, though few recognize it. Neptune is fainter still, invisible without optics. They are triumphs of modern astronomy. Uranus discovered by William Herschel in 1781. Neptune in 1846, seen first on paper, its position predicted by calculation. Viewing them today is casting your gaze to the edge of what's visible from Earth. Through a telescope, Uranus appears subdued and smooth. Neptune shows deep blue storm bands. They remind us that not every world shows itself hidden in the dim, slow, and quiet. They are silent sentries at the outer reaches of our planetary family, awaiting curious eyes. Comets sometimes sweep the night with glowing tails. Occasionally, a visitor from the solar system's depths arrives, an icy, dusty comet diving toward the sun. As it warms, gas and dust stream out, forming a bright coma and tails that can stretch millions of kilometers. The tails always point away from the sun, shaped by solar wind and radiation. Some comets blaze, commanding the sky for weeks. Hale-Bopp in 1997 and Neowise in 2020 captivated millions. Others are only faint whispers in a telescope. Comets always spark wonder because they arrive unexpectedly and vanish without notice, unlike planets and fixed stars. They are fragments from the solar system's dawn ice archives, carrying secrets of our beginnings. Watching a comet sweep by is to see a messenger from the far dark, fleeting yet timeless. Some comets return only after thousands of years. Their orbits are vast. Some circle the sun in a few years, others need millennia. The long-period ones may appear once in the historical record, then vanish into the void until a far future generation meets them again. Their paths reach beyond Pluto into the Oort cloud, a vast icy reservoir at the solar system's edge. Nudged by gravity, they begin journeys measured not in lifetimes but in civilizations. By the time they return, languages have changed, empires have risen and fallen, and the world itself may be different. Imagine an ancient observer recording a comet thousands of years ago, never knowing that the very same object would blaze again in our time. Long-period comets connect past and present, each return like a stitch sewing together generations who once looked up at the sky. Halley's Comet visits about every 76 years. Among comets, Halley is legendary, bright, reliable, and well recorded. Returning on average every 76 years. Its traces are woven into human history. Ancient Chinese astronomers chronicled it. It appears on the Bayeux Tapestry in 1066 as an omen of conquest. Mark Twain was born when it arrived in 1835 and died when it returned in 1910, just as he predicted. Halley's orbit dives deep into the inner solar system where sunlight burns its ices and makes it flare. Generations pass between its visits, turning it into a link between grandparents and great-grandchildren, a reminder that a human life is brief beside cosmic cycles. Its next appearance will be in 2061, another reminder of time's continuity stretching beyond any single lifetime. For centuries, comets were feared as omens of disaster. Before science unpacked their nature, comets inspired dread. Unlike familiar stars and planets, they appeared suddenly blazing without warning. To the ancients, their arrival foretold upheaval, war plagued the deaths of kings. The Chinese kept meticulous records, treating each comet as a message from the heavens. In Europe, they were hairy stars, linked with fire and blood. Not until the 17th century did astronomers like Edmund Halley gradually understand them as natural phenomena, icy travelers on predictable orbits. Today, comets evoke curiosity more than fear. Yet history's weight remains imagining a medieval farmer staring up at a brilliant comet. We can feel the primal awe these unexpected visitors once inspired. They're not just beautiful, they are omens from the far dark. Some comets shatter right before our eyes. Not every comet survives its passage toward the sun. Some become unstable as heat cracks their icy bodies. They break apart in plain view. In 1994, comet Shoemaker-Levy 9 fragmented and plunged into Jupiter, leaving scars larger than Earth. More recently, comet Ison, once expected to be dazzling in 2013, disintegrated as it skimmed the sun, leaving only a faint trace. Watching a comet fall to pieces reminds us of its fragility, loosely bound remnants from the solar system's dawn. They can flare suddenly and then vanish forever, destroyed by the very star that made them shine. Those fiery deaths also teach us about comet composition, unlocking secrets from the planet-forming era. And dying comets remind us how delicate the building blocks of worlds can be. Auroras drape the night sky with trembling curtains of light. In the far north and south, night can brighten with otherworldly glow. Green, purple, and red curtains ripple above, thickening and thinning as if drawn by an invisible hand. These are auroras, the northern and southern lights. They form when charged particles from the sun stream toward Earth and collide with our atmosphere, exciting atoms to emit light. Each color comes from a different gas. Oxygen glows green and red. Nitrogen gives off blue and violet. To those who see them, auroras feel alive, moving and pulsing to a rhythm beyond our world. They've inspired legend for millennia, dancing spirits, ancestors, speaking battles in the sky. Even when we know the physics, the beauty remains. Standing beneath an aurora is to feel the bond between earth and sun overhead, written in light across the night's canvas. These displays begin when the solar wind slams into Earth's atmosphere. Auroras originate far away on the sun, where flares and coronal mass ejections launch streams of charged particles into space. Some of those particles reach Earth, where our magnetic field guides them toward the poles. There they slam into the upper atmosphere, colliding with oxygen and nitrogen atoms. Those atoms absorb energy and release it as light, creating shimmering, dancing shows over the polar skies. The process is invisible from space, but on the ground it's breathtaking. Stronger solar storms make the lights brighter and push them farther from the poles, sometimes as far as the Mediterranean or the southern United States. Every aurora is unique, sculpted by the solar wind's strength and direction. To witness one is to see Earth's shield at work, transforming the sun's invisible fury into beauty, violence turned into radiant calm. In the far north, auroras can appear nearly every night. For people at high latitudes, auroras aren't rare miracles. They're returning companions. In Alaska, northern Canada, Scandinavia, and Siberia, the auroral oval arches across the sky. During long winter nights, the lights can appear several times a week, sometimes almost nightly. Indigenous communities grow up with that glow on cold evenings. You can step outside and see the horizon throb green or curtains of light ripple overhead. Travelers journey great distances, hoping for a glimpse, waiting hours in frigid darkness. The regularity of auroras in these places is a gift of geography. Earth's magnetic field funnels solar particles there more often than anywhere else. Even for those who see them often, auroras never lose their magic. predictable yet surprising, familiar yet never the same. Each night the sky is repainted by the sun's invisible wind. Auroras also ripple on planets beyond Earth. We're not alone in wearing these luminous veils. Planets with magnetic fields have aurora too. On Jupiter, they're enormous, powered not only by the solar wind, but also by material spewed into space by the volcanic moon Io. Those auroras can dwarf Earth, glowing in ultraviolet, invisible to human eyes. Saturn has its own arcing around the poles. Even Uranus and Neptune have auroras shaped by their tilted magnetic axes. Mars, with only remnants of a magnetic field, hosts patchy, localized auroras. Studying these lights across the solar system shows how planets interact with their stars and their own magnetic environments, and reminds us that auroras aren't Earth's exclusive spectacle. They're a cosmic phenomenon wherever charged particles meet magnetic field lines. The beauty we see is a universal signature of energy. The zodiac constellations once guided planting and harvest. Long before paper calendars, people looked to the stars for cues. The zodiac 12 constellations along the sun's path became a calendar in the sky. Farmers learned that when certain stars rose at dawn or set at dusk, the seasons were turning. The appearance of Virgo or Taurus could signal planting time. The return of Scorpius marked harvest. That practical knowledge helped civilizations thrive, tying human survival to the sky's motions. Over time, the zodiac grew beyond a calendar, evolving into astrology, linking constellations with personality and fate. But its roots were deeply practical, the need to measure time and anticipate Earth's cycles. Today, the zodiac remains familiar even though the stars have shifted slightly due to Earth's slow axial wobble. Those constellations remind us of the deep bond between human life and the rhythms of the cosmos. The ecliptic traces the sun's yearly path through the constellations. If you observe the sun each day from the same place, it doesn't wander randomly. It follows a steady route, drawing a great circle in the sky over a year. That route is the ecliptic. Along it, the sun seems to move from one constellation to the next, ushering in the seasons. The moon and planets also stay near this line. Their orbits lie close to Earth's orbital plane. For ancient observers, the ecliptic wasn't just a pattern. It was the backbone of the sky, the stage where the most important actors appeared. Even now, astronomers use it to map planetary positions, and astrologers place their signs upon it. When you track the ecliptic, you're following humanity's first calendar, a groove in the sky carved by Earth's journey around the star that sustains us. Precession slowly shifts star positions over millennia. The stars seem eternal, fixed in their patterns, but they don't stand still. Over thousands of years, Earth's axis wobbles like a spinning top, a slow motion called precession, gradually moving star positions in our sky. Today, Polaris sits close to the north celestial pole, serving as our North Star. But in ancient Egypt, about 5,000 years ago, another star, Thuban, held that spot. In roughly 12,000 years, Vega will shine where Polaris is now. Constellations shift subtly too, their outlines changing as the backdrop turns. To us, these changes are too slow to notice. Across civilizations, they matter. They skew calendars and misalign temples built to track the sky. Precession reminds us that even what seems immutable is moving quietly, rewriting the heavens. The night sky looked different when dinosaurs roamed Earth. Imagine standing here 100 million years ago when giant reptiles ruled. Look up the constellations we know hadn't yet taken shape. Stars drift through time. Orion, Ursa Major, and Scorpius were arranged differently then. Some patterns didn't resemble anything we'd recognize. Others were warped into unfamiliar forms. The Milky Way still spanned the sky, but its filigree looked a bit different. Our human ancestors never saw that view, but dinosaurs did under a sky whose stars have since moved on. Thinking about such deep change reminds us how dynamic the universe is. Even the landmarks of constellations are temporary, delicate drawings in motion. Millions of years from now, the future sky will look strange to human eyes, just as it once did to the dinosaurs. Some stars move so fast that they distort constellations over time. Constellations aren't permanent, they're illusions of perspective. Stars at very different distances happen to align from our viewpoint. Over time, each star drifts slowly, altering those lines of light. Most motion is too small to notice, but a few fast movers glide across the background at unusual rates. Over thousands of years, they warp constellations. Orion's belt will lose its straight line. The Big Dipper will change shape. These shifts outpace a single lifetime, but across millennia, the sky transforms. Astronomers measure these shifts as proper motion, subtle changes relative to the distant background. By mapping them, we can forecast the future sky or reconstruct the ancient one. The stars remind us that constellations aren't carved in stone, but fleeting arrangements, temporary patterns in a universe where everything is always in motion. Barnard's star slides across the sky faster than almost any other. A faint reddish star moving against the stellar background with near unmatched speed. Barnard's star, a dim red dwarf, only 6 light-years away, shifts its position enough to be detected within a human lifetime. Astronomers call this proper motion, and Barnard's is the largest of any known star. Year by year, it creeps along a restless traveler among our stellar neighbors. Though invisible to the naked eye, it has drawn scientific attention for over a century. There was a time when people thought it had planets, sparking speculation about life beyond Earth. Those worlds proved elusive, but the fascination remains. Barnard's star is very old, perhaps twice the sun's age, and will keep drifting long after our world is gone. It reminds us that the fixed stars aren't fixed at all. They wander, and some wander faster than others. Satellites drift like artificial stars across the night. If you watch carefully after sunset, you may spot a steady point of light gliding overhead. Unlike airplanes, it's silent and doesn't blink. That's a satellite reflecting sunlight as it orbits Earth. Thousands of satellites circle above us, creating a quiet population of artificial stars. Their paths are predictable, rising in the west, sliding east, then fading as they enter Earth's shadow. The early Sputnik shocked the world. Its faint beeps were thrilling and unsettling. Today, dense satellite constellations crowd the sky for communication, weather, and navigation, but their growing numbers raise concerns about a busy heavens. For stargazers, catching a satellite still brings wonder. Seeing a human-made star drift by is to glimpse our footprint against the ancient sky. The International Space Station, ISS, often outshines everything but the moon. The ISS, a flying laboratory about 400 kilometers up, is one of the brightest objects in the night sky. When sunlight hits its huge solar panels just right, it can outshine every star and sometimes rival Venus. To the naked eye, it's a fast-moving star crossing the horizon in just a few minutes. For those who know when and where to look, it's a joyous moment, a reminder that people are up there circling the planet at over 27,000 km. Inside, astronauts live and work running experiments and watching Earth drift below them 16 times a day. The station itself is a symbol of cooperation built by many nations working together. Each time it passes overhead, it links the vast sky with the human story, a bright reminder of our fragile presence in space. Satellite flares can sometimes rival Venus. Some satellites don't just glide by, they suddenly flash. When sunlight reflects off their surfaces at just the right angle, they flare brilliantly, outshining nearly everything else in the sky. The iridium generation with flat antennas was once famous for this, producing dazzling flares, even in cities at times as bright as Venus. They last only a few seconds before fading back into the background. To astronomers, they're both nuisance and marvel, a kind of light pollution, yet also a vivid example of orbital mechanics. As satellite designs change and the classic iridium flares recede into the past, new reflections can still surprise sky watchers. Catching a sudden spark from an artificial star is witnessing a game between sunlight, geometry, and technology, a fleeting spark that links Earth with machines in orbit. Sometimes rockets paint glowing clouds high in the atmosphere. During launch, a rocket's fiery engines slice through the air, leaving bright trails hundreds of kilometers long. At high altitudes, those exhaust plumes expand and catch sunlight even when the ground below is dark. The result is a spectacular scene, luminous clouds twisting, blooming, and shimmering with rainbow hues as ice crystals scatter light. For those who aren't expecting it, the sight can be startling, as if supernatural. In truth, it's human technology meeting the thin upper air, where sunlight and atmosphere conspire to create beauty. These displays can be seen across wide regions, turning ordinary evenings into unforgettable moments for anyone who happens to look up. They remind us that even rocket work machines of fire and force can leave behind moments of wonder lightly written across the sky. The night sky is growing crowded with human-made lights in orbit. For most of history, the sky belonged to nature stars. Planets, comets, and meteors were the only moving lights. But in just a few decades, we've added thousands of our own stars. Satellites, space stations, and orbital debris now encircle our planet. Many reflect sunlight as they pass overhead. To the naked eye, they appear as moving stars slicing through constellations and drawing streaks in long exposure photos. For astronomers, the swelling swarms pose challenges, interfering with observations and leaving trails across cosmic images. For casual sky watchers, though, the sight can feel strange, yet warming proof that Earth has reached into space, leaving a quiet signature of our presence. The sky has become a shared domain between natural wonders and human creations. Each artificial light is a reminder of our species' ambition and how quickly we've stamped even the quietest places with traces of ourselves. The Hubble Space Telescope has revealed breathtaking deep-sea vistas. Launched in 1990, Hubble showed us the universe in a way we had never seen before. Cruising above Earth's blurry atmosphere, it captured images with a sharpness hard to match from the ground. Its photographs of galaxies, nebulae, and star clusters became iconic flooding books and screens with color and detail. The pillars of creation. The Sombrero Galaxy and countless star-forming clouds entered our imagination thanks to Hubble. Beyond beauty, Hubble delivered core science, helping measure the universe's age, track the expansion of space, and unveil secrets of distant worlds. For more than 3 decades, it has orbited Earth, opening a window into the depths of time and space. Each of its images reminds us that the universe isn't an abstract idea, but a boundless realm of beauty, patiently waiting to be explored. Every black patch hides a swarm of galaxies. If you pick a seemingly empty patch of night sky and look deeply, you might expect only darkness. But when astronomers aim powerful telescopes into such regions, they find something astonishing. Within that apparent void are thousands of galaxies, each holding billions of stars. Every tiny speck captured is its own cosmic island at distances beyond imagination. Realizing this is humbling, the emptiest corner of the sky is anything but empty. That space is thick with galaxies, layered in time, their light traveling billions of years to reach us. Which means that when we look into the dark, we're not facing emptiness, but abundance. The quiet regions of the night hold far more worlds than we think, hiding richness behind stillness. Empty, in the end, is an illusion. Hubble's deep field revealed thousands of galaxies in a sky patch no bigger than a grain of sand. In 1995, astronomers pointed Hubble at a patch of sky so tiny it seemed utterly blank. For 10 days, the telescope patiently gathered faint light. The result was extraordinary: nearly 3,000 galaxies within that tiny frame. Later, deep fields revealed tens of thousands. To grasp the scale, hold a grain of sand at arm's length. The area it covers is roughly the size of the Hubble Deep Field. If that many galaxies exist in such a minuscule slice of sky, the whole universe must hold hundreds of billions. Each galaxy has billions of stars. Each star may host worlds and perhaps life. That single experiment reshaped astronomy, proving the universe is richer and more crowded than even our boldest guesses. It showed that even the most ordinary dark patch hides unimaginable abundance. Time itself flows differently across the universe. Einstein's theory shows time isn't universal. It bends and stretches under gravity and motion. A clock near a massive star will tick more slowly than one farther away. A traveler moving near light speed experiences time differently from someone standing still. The universe then has no single beat, only countless rhythms woven together. In extreme places, like near a black hole, time slows dramatically, nearly to a stop, when seen from afar. Even astronauts in orbit experience minute differences from us on the ground, their clocks running slightly faster or slower depending on altitude. Time isn't fixed, it's elastic. The sky reminds us that even something as fundamental as time is part of the universe's strange fabric, shaped by gravity and motion. Every star in the night sky is a glimpse into the past. When you look at the stars, you're not seeing them as they are now. Light takes time to travel. Even the nearest star after the sun is over 4 light years away. Many stars are hundreds, thousands, even tens of thousands of light years distant. So the light you see began its journey long before the moment you look, carrying a slice of the past. Some stars you admire may already have died, their fuel spent, their light gone, even as their final photons are still on their way to Earth. To look up is to look back. The night sky is a cosmic archive. Each star is a page written in light, reaching us only after unimaginable journeys across vast distances. Some objects are so distant that their light set out before humans existed. There are stars and galaxies so far away that their light has been traveling for millions of years since Earth belonged to the dinosaurs, or even before mammals. The photons touching your eyes tonight began long before humanity, before forests, before flowering plants. Some of that light left when the universe was so young that galaxies were just beginning to take shape. Seeing such distant objects is stepping out of human history into a timeline written in distance and starlight. Then stars become more than the night's adornments. They are messengers of deep time, telling stories older than humanity, older than living Earth itself. The cosmic microwave background is the afterglow of creation. In every direction, a faint radiation blankets the sky, invisible to our eyes but detectable with radio antennas. This is the cosmic microwave background, CMB, the descendant light of the Big Bang. Nearly 14 billion years ago, the universe was hot, dense, and filled with light trapped in a thick plasma. As the universe expanded and cooled, that light finally escaped, flooding space. What remains today is a faint echo, chilled to just a few degrees above absolute zero, yet present everywhere. Discovered by chance in the 1960s, the CMB has since become one of our most important clues to our origins. Tiny ripples in this afterglow reveal where future galaxies would form. Studying it is like peering into the universe's infancy when the first light escaped into darkness, and the earliest memory of creation was written across the sky. Though invisible to the naked eye, the CMB saturates all of space. It doesn't belong to any one corner of the sky, it fills the universe. Point an antenna anywhere at the right frequency, and the signal is their faint uniform, ancient. In fact, a small fraction of the static on old TVs came from this background, radiation whispers of the universe's dawn, leaking into every home. Though unseen, its presence is undeniable. It tells us the universe was once unimaginably hot and uniform before expanding into the vast, varied place we know today. Knowing that every stretch of space carries the same signature is humbling. Wherever you stand on Earth, or anywhere else, you're bathed in the same fossil glow, a quiet memory of creation lingering around us. Long ago, the sky lit up with the first galaxies at the cosmic dawn. Billions of years ago, when the universe was young, the first galaxies began to take shape. Clouds of hydrogen and helium collapsed under gravity, igniting the first stars. Massive, brilliant, short-lived, living, fast and dying in dazzling explosions. Their deaths scattered heavy elements across space, raw material for planets and life. Those early galaxies were small and chaotic compared to today's grand spirals and ellipticals, but they were the pioneers stitching light into the dark. Astronomers call that era the cosmic dawn, when the universe first glowed with starlight. To see them, we must peer across vast distances and times, catching their faint light more than 13 billion years in the past. They remind us that everything we see today, every star, every world, every living thing traces its lineage to that dawn. The James Webb Space Telescope is turning its gaze to that dawn. Launched in 2021, the James Webb Space Telescope was built to look farther back in time than any telescope before it. With its giant gold-coated mirror and infrared instruments, Webb can capture the faint light of galaxies that formed just a few 100 million years after the Big Bang. Webb has revealed early galaxies brighter and bigger than expected, challenging our understanding of how quickly the universe grew. Its images show newborn stars swaddled in dust planets around distant suns, and light stretched redward by the universe's expansion. Webb is opening epochs. We once could only imagine bringing us closer to the cosmic dawn, the moment the first galaxies lit up. Each discovery reminds us that the universe still holds surprises waiting to be unveiled in the faint light that has traveled billions of years to reach us. Some stars orbit the Milky Way's center at staggering speeds. At the heart of the Milky Way lies a supermassive black hole, a gravitational anchor around which everything moves. Most stars circle the galactic center, leisurely taking hundreds of millions of years per orbit. Closer in the tempo becomes astonishing. Some so-called S-stars whip around the black hole at thousands of kilometers per second, completing a lap in just a few years. Tracking them has given astronomers direct evidence of the black hole's immense pull, a power seen only through the frantic dance of nearby stars. From Earth, they're just faint points. Their motion tells the tale. They remind us that even the quiet sky above is packed with furious speed and invisible gravity. Hypervelocity stars get slingshotted like stones from a sling. Sometimes a star has a deadly encounter with the black hole at the galaxy's center. If it ventures too close, tidal forces can tear a binary apart, capturing one star while flinging the other outward at unbelievable speed. These exiles are called hypervelocity stars, racing through the Milky Way at millions of kilometers per hour, fast enough to one day escape the galaxy. To the eye, they look ordinary. Precise measurements reveal their extraordinary speed. They're cosmic runaways, slung from home by gravity's sling. Each carries a chaotic history, the story of a near miss with destruction. It's humbling to imagine entire suns being hurled into intergalactic space, a whole star cast out, wandering alone in the endless dark, never to return to the galaxy that birthed it. Rogue planets pass invisibly through the night with no sun of their own. Usually, planets are bound to their stars. Not all keep their ties. Some are ejected from their systems, drifting through the galaxy. Rogue planets, lonely worlds with no warming sun. Invisible to the naked eye, their numbers may be in the billions, perhaps even exceeding the number of stars. The station itself is a symbol of cooperation built by many nations working together. Each time it passes overhead, it ties the vast sky to the human story, a bright reminder of our fragile presence in space. Satellite flares can sometimes rival Venus. Some satellites don't just drift by, they suddenly flash. When sunlight reflects off their surfaces at the perfect angle, they blaze brilliantly, brighter than almost anything else in the sky. The iridium generation with flat antennas was once famous for this, producing blinding flares, even in cities sometimes as bright as Venus. They last only a few seconds before fading into the background. To astronomers, they're both annoying and astonishing, a kind of light pollution, but also a vivid demonstration of orbital mechanics. Even as satellite designs change and classic iridium flares fade into the past, new reflections can still catch skywatchers off guard. Seeing a sudden glint from an artificial star is witnessing a game between sunlight geometry and technology, a fleeting spark linking Earth to machines in orbit. Sometimes rockets paint glowing clouds high in the atmosphere. During launch, a rocket's fiery engines slash through the air, leaving bright trails hundreds of kilometers long. At high altitudes, those exhaust plumes expand and catch sunlight even when the ground below is dark. The result is spectacular luminous clouds, twisting, blooming, and shimmering with rainbow hues as ice crystals scatter the light. For those who don't know what's coming, the sight can be startling, almost supernatural. In reality, It's human technology meeting the thin upper air where sunlight and atmosphere combine to create beauty. These shows can be seen across wide regions, turning ordinary evenings into unforgettable moments for anyone who happens to look up. They remind us that even rockets' machines of fire and force can leave behind moments of wonder lightly written across the sky. The night sky is getting crowded with human-made lights in orbit. For most of history, the sky belonged to nature stars. Planets, comets, and meteors were the only moving lights. But in just a few decades, we've added thousands of our own stars. Satellites, space stations, and space debris now encircle our planet. Many reflect sunlight as they pass overhead. To the naked eye, they look like moving stars, cutting through constellations and streaking long exposure photos. For astronomers, the growing swarms are a challenge, disrupting observations and leaving trails across images of the cosmos. For casual stargazers, though, the sight can feel oddly heartening proof that Earth has reached into space, leaving a quiet signature of our presence. The sky has become a shared realm between natural wonders and human creations. Each artificial light is a reminder of our species' ambition and how quickly we've marked even the quietest places with traces of ourselves. The Hubble Space Telescope has revealed breathtaking deep-sea vistas. Launched in 1990, Hubble showed us the universe as never before. Flying above Earth's hazy atmosphere, it captured images with sharpness hard to match from the ground. Its photographs of galaxies, nebulae, and star clusters have become iconic, filling books and screens with color and detail. The Pillars of Creation. The Sombrero Galaxy and countless star-birthing clouds entered our imagination thanks to Hubble. Beyond beauty, Hubble delivered foundational science, helping measure the age of the universe, track the expansion of space, and reveal secrets of distant worlds. For more than 3 decades, it has orbited Earth, opening a window onto the depths of time and space. Each of its images reminds us that the universe isn't an abstract idea, but a boundless realm of beauty, patiently waiting to be explored. Every black patch hides a swarm of galaxies. If you pick a seemingly empty patch of night sky and look deeply, you might expect only darkness. But when astronomers point powerful telescopes at such regions, they find something astonishing. Within that apparent void are thousands of galaxies, each containing billions of stars. Every tiny speck in the image is its own cosmic island, unimaginably far away. It's humbling to realize the emptiest part of the sky isn't empty at all. That space is dense with galaxies layered across time, their light traveling billions of years to reach us. Which means when we look into darkness, we're not seeing emptiness, but abundance. The quiet regions of night hold more worlds than we imagine, hiding richness behind stillness. Empty is, in the end, an illusion. Hubble's deep field revealed thousands of galaxies in a patch of sky no bigger than a grain of sand. In 1995, astronomers aimed Hubble at a sky area so tiny it seemed utterly blank. For 10 days, the telescope patiently gathered faint light. The result was extraordinary: nearly 3,000 galaxies in that tiny frame. Later, deep fields revealed tens of thousands. To grasp the scale, hold a grain of sand at arm's length. The area it covers is roughly the size of the Hubble Deep Field. If that many galaxies exist in such a minuscule slice of sky, the whole universe must contain hundreds of billions. Each galaxy has billions of stars. Each star may host worlds, perhaps even life. That single experiment changed astronomy, proving the universe is richer and more crowded than even our boldest guesses. It showed that even the most ordinary dark patch hides unimaginable abundance. Time itself flows differently across the universe. Einstein's theory shows time isn't universal. It bends and stretches under gravity and motion. A clock near a massive star will tick more slowly than one farther away. A traveler moving near the speed of light experiences time differently from someone standing still. This means the universe has no single beat, only countless rhythms woven together. In extreme places like near a black hole, time slows dramatically, nearly to a standstill, as seen from outside. Even astronauts in orbit experience tiny differences from us on the ground, their clocks running slightly faster or slower depending on altitude. Time isn't fixed, it's elastic. The sky above reminds us that even something as fundamental as time is part of the universe's strange fabric shaped by gravity and motion. Every star in the night sky is a glimpse into the past. When you look at the stars, you're not seeing them as they are now. Light takes time to travel. Even the nearest star after the sun is more than 4 light years away. Many stars are hundreds, thousands, even tens of thousands of light years distant. So the light you see began its journey long before the moment you look, carrying a slice of the past. Some stars you admire may already have died, their fuel spent, their light extinguished, even as their last photons are still en route to Earth. To look up is to look back. The night sky is a cosmic archive. Each star is a page of history written in light, reaching us only after unimaginable journeys across vast distances. Some objects are so distant that their light set out before humans existed. There are stars and galaxies so far away that their light has been traveling for millions of years, from times when Earth belonged to dinosaurs, or even before mammals. The photons touching your eyes tonight set out long before humanity, before forests, before flowering plants. Some of that light left when the universe was so young that galaxies were only beginning to take shape. Seeing such distant objects is stepping out of human history into a timeline written in distance and starlight. Then stars are more than ornaments of the night. They are messengers of deep time, telling stories older than humanity, older than living Earth itself. The cosmic microwave background is the afterglow of creation. In every direction, a faint radiation blankets the sky, invisible to our eyes, but detectable with radio antennas. This is the cosmic microwave background, CMB, the descendant light of the Big Bang. Nearly 14 billion years ago, the universe was hot, dense, and filled with light trapped in a thick plasma. As it expanded and cooled, that light finally escaped flooding space. What remains today is a faint echo, chilled to just a few degrees above absolute zero, yet present everywhere. Discovered by accident in the 1960s, the CMB has become one of our most important clues to our origins. Tiny ripples in this afterglow reveal where future galaxies would form. Studying it is like peering into the universe's infancy, when the first light slipped into darkness and the earliest memory of creation was written across the sky. Though invisible to the naked eye, the CMB saturates all of space. It doesn't belong to any one corner of the sky, it fills the universe. Point an antenna anywhere at the right frequency, and the signal is there, faint, uniform, ancient. In fact, a small fraction of the snow on old TVs came from this background radiation whispers of the universe's dawn slipping into every home. Unseen as it is, its presence is undeniable. It tells us the universe was once unimaginably hot and uniform before expanding into the vast, varied place we know today. It's humbling to know that every stretch of space carries the same signature. Wherever you stand on Earth or anywhere else, you're bathed in the same fossil glow, a quiet memory of creation lingering around us. Long ago, the sky lit up with the first galaxies at the cosmic dawn. Billions of years ago, when the universe was young, the first galaxies began to take shape. Clouds of hydrogen and helium collapsed under gravity, igniting the first stars, massive, brilliant, short-lived, living fast and dying in dazzling explosions. Their deaths scattered heavy elements across space, raw material for planets and life. Those early galaxies were small and chaotic compared to today's grand spirals and ellipticals, but they were pioneers stitching light into the dark. Astronomers call that era the cosmic dawn, when the universe first glowed with starlight. To see them, we must peer across immense distances and times, catching their faint light more than 13 billion years in the past. They remind us that everything we see today, every star, every world, every living thing, traces its lineage to that dawn. The James Webb Space Telescope turns its gaze back to that dawn. Launched in 2021, the James Webb Space Telescope was designed to look farther back in time than any telescope before it. With its giant gold-coated mirror and infrared instruments, Webb can capture the faint glow of galaxies that formed just a few 100 million years after the Big Bang. Webb has revealed early galaxies brighter and bulkier than expected, challenging our understanding of how quickly the universe grew. Its images show newborn stars swaddled in dust planets around distant suns, and light stretched redward by the universe's expansion. Webb is opening epochs we once could only imagine, bringing us closer to the cosmic dawn when the first galaxies lit up. Each discovery reminds us that the universe still holds surprises waiting to be revealed in the faint light that has traveled billions of years to reach us. Some stars orbit the center of the Milky Way at staggering speeds. At the heart of the Milky Way lies a supermassive black hole, a gravitational anchor around which everything circles. Most stars move around the center, lazily taking hundreds of millions of years per orbit. Closer in the tempo becomes astonishing. Some S-stars whip around the black hole at thousands of kilometers per second, completing a lap in just a few years. Tracking them has given astronomers direct evidence of the black hole's immense pull, a power revealed only by the frantic dance of nearby stars. From Earth, they're just faint points. Their motion tells the story. They remind us that even the quiet sky above is full of furious speed and invisible gravity. Hypervelocity stars get slingshotted like stones from a sling. Sometimes a star has a deadly encounter with the black hole at the galaxy's center. If it ventures too close, tidal forces can rip a binary apart, capturing one star while hurling the other outward at unbelievable speed. These exiles are called hypervelocity stars, racing through the Milky Way at millions of kilometers per hour, fast enough to escape the galaxy one day. To the eye, they look ordinary. Precise measurements reveal their extraordinary speed. They're cosmic runaways, flung from home by gravity's sling. Each carries a turbulent history, the tale of a brush with annihilation. It's humbling to imagine entire suns hurled into intergalactic space, a whole star cast out wandering alone in endless dark, never to return to the galaxy that birthed it. Rogue planets pass invisibly through the night with no sun of their own. Usually, planets are bound to their stars. Not all keep their ties. Some are ejected from their systems, drifting through the galaxy. Rogue planets, lonely worlds with no warming sun. Invisible to the naked eye, their numbers may be in the billions, perhaps even exceeding the number of stars. Some may carry thick atmospheres or hidden oceans kept warm by internal heat or radioactive decay. If life could exist in such places, it would live in eternal night forever, hidden from starlight. Astronomers detect these worlds through subtle gravitational effects, watching background starlight bend as a wandering planet passes in front. Each discovery deepens the mystery. How many such exiles drift unseen between the stars? They remind us that not every planet belongs to a familiar family. Many worlds travel alone, quietly and coldly through cosmic space. Vast dust clouds hide entire regions of the sky. The sky seems crystal clear, but great swaths of space are veiled interstellar dust particles, finer than smoke, drifting in large clouds that block visible light. These clouds can obscure whole clusters, turning star-rich regions of the Milky Way into dark patches. To ancient observers, they look like holes in the sky, where no stars existed. Today, we know they're nurseries, places where stars are born from collapsing gas. Inside, gravity gathers matter until new suns ignite. Dust both conceals and creates. It hides brilliance while shielding fragile beginnings from harsh radiation. In infrared and radio, astronomers can see through revealing structures invisible to the eye. The darkness between stars turns out to be full of birth and becoming. Infrared light slips through those clouds, exposing hidden suns. Though dust blocks visible light, longer wavelengths pass through. Infrared radiation, invisible to our eyes, reveals stars and structures within dark nebulae. Telescopes tuned to the infrared can see newborn suns glowing in their cradles, wrapped in cocoons of dust. They also uncover planet-forming disks, the seeds of solar systems around young stars. Missions like the Spitzer Space Telescope and the James Webb Space Telescope have transformed our view, turning dense, featureless shadows into lively landscapes of hidden light. Where the naked eye sees only black, the infrared shows clusters of suns, filaments of gas, and galaxies cloaking themselves in dust. It's like pulling back the universe's curtain to reveal what lies beneath. The cosmos isn't empty where it looks dark. It's packed with concealed splendor, waiting for the right way of seeing to bring it into view. Radio waves from quasars have traveled billions of years to reach us. These are fiercely active galaxies with supermassive black holes at their cores. As matter spirals into these black holes, it heats to extreme temperatures, emitting radiation across the spectrum, especially in radio. Those signals cross unimaginable distances, traveling for billions of years before they reach Earth. Quasars are so far away that many of them shine from an era when the universe was very young, only a small fraction of its current age. They're lighthouses from the deep past, sending steady emissions through time and space. Radio telescopes on Earth catch their faint whispers, turning them into data that reveals how galaxies and black holes grew. To listen to a quasar is to hear the echo of a universe in its adolescence voices carried from the opening chapters of creation. Some quasars are brighter than an entire galaxy combined. Powered by black holes, quasars are anything but dark. A single quasar can outshine all the stars in its host galaxy. Their brilliance comes from infalling matter heated to millions of degrees. Some launch particle jets millions of light-years long, colossal beams visible across the cosmos. To the naked eye, a quasar would look like a dim star. But behind that point is energy greater than a whole galaxy. They're cosmic paradoxes where destruction and creation intertwine. Quasars light up the distant universe, marking galaxies from the era when the cosmos was still assembling. Their light crosses billions of years to reach us, a record both violent and beautiful. Knowing such brilliance exists so far away makes clear just how powerful the universe's engines really are. Gamma-ray bursts blaze for moments yet outshine the universe. Among the most violent events known are gamma-ray bursts, fleeting explosions that release more energy in seconds than the sun will emit in its entire lifetime. They're thought to occur when massive stars collapse into black holes or when neutron stars collide, sending shockwaves into space. For a brief instant, their light can outshine all the stars in the observable universe. Most last only seconds, some just milliseconds, then fade, leaving afterglows detectable in X-ray and radio. They're so distant that their light often set out billions of years ago and still blinds our instruments today. Invisible to the naked eye, these bursts are caught by specialized satellites that alert astronomers to their transient appearance. Witnessing that power, even indirectly, is to confront the universe's extremes, explosions that briefly overshadow the work of creation before falling back into silence. The night sky thrums with signals across the electromagnetic spectrum. When we look up, our eyes catch only a narrow band visible light. But the universe hums with signals across the whole spectrum, radio from distant quasars, microwaves echoing the universe's birth, infrared from dust clouds, ultraviolet pouring from hot young stars, X-rays blazing around black holes, and gamma rays from cataclysms. Each band reveals a different layer of the same story. The sky that seems quiet is actually ringing with information, a symphony of light at many frequencies. Astronomers build instruments to listen to these bands and piece together a fuller picture of the cosmos. Looking only in visible light is like hearing just one note of a grand chord. The sky above is neither silent nor still. It's alive with hidden energy signals woven through the dark, carrying the history of everything. Every time you look up, you're looking into the universe's history. When you lift your eyes to the stars, you're not just seeing space, you're seeing time. Each point of light is a messenger from the past, its journey spanning years, centuries, or billions of years. The farther away, the older the story it carries. The nearest stars show us a few years ago. The Andromeda Galaxy shows us a few million years ago. The faintest galaxies we can detect show us the universe not long after the Big Bang. The sky is a vast archive, layers of light like pages. Every upward glance belongs not to the present, but to memory, the universe showing us itself as it once was. To lie beneath the stars is to lie beneath history, immersed in a chronicle, written in light reaching back to the dawn of time. And so, dear listener, our wander through the wonders above draws to a close. From the racing shadows of solar eclipses to the quiet glow of planets, from comets that come once in a lifetime to the gentle rippling curtains of aurora in polar skies. We've roamed a tapestry woven from light and time. We've glimpsed the brilliance of distant burning stars, felt the stillness of galaxies stretching into darkness, and traced the faint echoes of the universe's first morning still lingering overhead. The sky reminds us that existence is vast, ancient, and endlessly surprising. It shows us both the immensity of the cosmos and the fragile strands of light that connect us to it. Every star above is a messenger from the past. Every planet is a reminder of possibility. Every shadow and shimmer is a story still being written. As you lie here, letting your breath find a steady rhythm, imagine yourself beneath an endless vault of sky. Picture the stillness of a clear night, the cool air around you and constellations slowly wheeling overhead. See the Milky Way sweeping a bright arc through the dark, a comet trailing silver and far-off galaxies flickering like forgotten lanterns. Everything drifts into quiet, into memory, into dreams. The sky has steadied countless generations before us and will steady countless generations after. Its story isn't finished, and when we look up, neither is ours. Just as day yields to night, every waking thought slips gently into sleep. If you're still awake when you're ready, you can watch the next video on the Easy Sleep Science channel. But if your eyelids are heavy, let the stillness of the high sky hold you and guide you into peaceful rest. Close your eyes, take a deep breath and drift into sleep, into quiet, into the vast, timeless hush where even the stars keep watch. Sleep well.